So we just need to finish up section 4.3. Remember, this is solving logarithmic equations or solving equations using logarithms. Remember, the reason that we have logarithms is because we need to get this x out of the exponent, okay? And we need to get it on the main floor so that we can use all the algebra that we've done in the past. The only way we know how to do that right now is to get the bases the same. But sometimes you just can't get them the same, as in this equation, 2 to the x plus 1 equals 5. I can't turn a 5 into a 2 or 2 into a 5, so I cannot get those bases the same. We've already talked about logarithms and how to ride the roller coaster to go from logs to exponents and exponents back to logs, and we've done a little practice of that. We've also graphed some logarithmic equations or logarithmic functions. Logarithmic functions, notice that you have the base is a subscript and your x is on the first floor. You don't have any high flyers. Notice also the main thing with when you're graphing these is that the y-intercept, the vertical asymptote is the y-axis. So all of them have this vertical asymptote. That's what most students miss on the test. So let's practice a few. We talked about how when your base for your logarithm is bigger than 1, that this is going to be an increasing function. When it is a fraction between 0 and 1, it's going to be a decreasing function. So let's just graph some. But the minute you see logarithm, if you aren't shifting it right or left, you need to go ahead and draw that vertical asymptote, because again, that's what everybody misses. The two big points that you need to remember for this is 1, 0 and base 1. If you remember, if we were graphing 2 to the x, it was 0, 1 and 1 base, or 1, 2. So all we're doing is just switching these guys, okay? So this one, if I had y equals 5 to the x, my points would be 0, 1, and 1, 5. So I'm just flipping those. So I have 1, so this is my x, and this is log base 5, would be 1, 0, and base 1. So 1, 0 is going to be this point. That's going to be on all my log equations or log graphs, unless I move them. And then 5, 1. So that's going to be, excuse me, let me go back to that one. Sorry, it is 1, 0. 1, 0. There we go. And 5, 1. Okay, so let me show you where most students mess up. They will connect these and then keep on going. See how I crossed? See how I crossed it? I crossed that green line. You cannot do that. So it's going to come up and you're going to get really close to the y-axis. Okay, here's another one. Log base 1/3. Again, I've got my 2 points, 1, 0, and my base, 1/3, and 1. So let's graph those 2 points, 1, 0, and 1/3, 1. So notice this one is going to be coming down, and once again, I'm going to have my vertical asymptote. So it's going to go here and get as close as I can to that, and then it just swings around. Okay. So now we are doing the same thing. We have our log base 3, but now we have x plus 2. So again, I'm just going to shift that to the left. So I'm going to make my same points that I had before, which is my 1, 0, and my base 1, so that's 3, 1, but I'm not going to connect those, right? I'm going to move them to the left. Now, I would have put a vertical asymptote there, but instead, I'm going to move it, right, because we're shifting it to the left, so I'm going to the left 2, So instead of being on the y-axis, that's where it is. And then I'm going to shift my points to the left 2. So let's move my 1, 0 to the left 2, and this one to the left 2. So it's going to look like that. Okay. Let's do one more. What does this plus 2 do to it? This plus 2 is going to raise it 2, right? So that's going to go up 2. I'm going to do my same points where I have 1, 0, and my base, which is 4. 1, 2, 3, 4, 1. Okay. Now this one, notice I'm moving it up. So I'm not moving it left or right. So I'm going to keep this vertical asymptote. And then I just take my 2 points and move them up 2. So I'll move the 1, 0 up 2 and the 4, 1 up 2. And I then do the same thing, bring it down, get really, really close to the y-axis. Okay, so now let's review. Okay, let's review. We talked about reviewing last time, but we weren't really using it, so I didn't review too much. But this time we need to really review. Remember, when you had in Algebra 1, when you had two terms where the bases were the same, do you remember what you could do to those exponents, the 2 and the 3? We just added them. If they were one on top of each other, so if you were dividing, you remember we subtracted those guys. So, excuse me, this one should be a to the 5th. Then we've got a to the 3rd. When it was to the -2, we just put it underneath. And anything to the 0 is 1. And then the last thing was this. This one is the one that might be a little bit new to you. That's where we put 3, the base, excuse me, the root of this, or index. It is the root, the bottom of that fraction. Okay, so we're going to use these. So the first thing to note is that we're basically going to use this for my logs. Notice when it was multiplication, we added those together. So we're going to do the same thing. If you have multiplication, we can separate the logs and put an addition. So if you have multiplication inside, we are going to separate it. If you have division, remember in division, we subtracted. So that's what we're going to do. If you see a division, you're going to subtract. And then this is sort of new. If you have an exponent, you're going to bring it down front. Okay, that is the one that we're going to use the most. It's one of the most used properties in all of our logs. Okay, because you are taking an exponent that's high flying that we can't work with, and you're bringing it down front on the first floor, which allows you to work with it. All right, so here's a couple more properties that I want you to look at that we will be using. So one is anything to the 0 power. Anything to the 0 power, we said, was 1, right? So think of this, 5 to the 0 is 1. If I rode my roller coaster, I would say log base 5 of what? Log base 5 of 1 equals, notice how I went through my 0? Log base 5 of 1 equals 0. Well, that is also log base 7 of 1, and log base 32 of 1, and log base A. So log base A of 1, if I rode my roller coaster, log base A of 1 is going to be 0. So anytime you are taking the log, it doesn't matter the base of 1, that's going to be 0. Now this one's a little bit more interesting. Notice I have 2 to some power is going to be equal to 2 to the 3rd. Well, that question mark is going to be 3. This one, 11 to some power is 11 to the 6th. Well, that's going to be 6. So A to some power, that's going to be x. A to x equals A to the x. If I ride my roller coaster, log base A of A to the x is going to be my x. So notice something pretty cool. Those bases essentially cancel each other out. So here is a base. There's the base of my log. Here is the base of my exponent. They're both called bases. When those guys are the same, they just cancel each other out, and this is your answer. Okay, and the same thing with number 3. This is the base of an exponent. Here is the base of the log. When they are the same, your answer is just going to be x. So that's I call that mathematical magic. Okay, so in example 5, we're going to be expanding our expression. Really, expanding the expression is just practice. What we do most of the time is condense it. But we want to get used to expanding, and I will be asking you on your test to expand as well. So I have log base 7 of 8 times 6. So I'm going to expand it. I'm going to have log base 7 of 8. And then I'm going to have log base 7 of 6. So I took these two and I expanded it. And when I see a times sign, do you remember what we do instead of times, multiply? We're going to add, right? So this might help us. Let me write that up here. So if you see a times sign, you are going to add. If you see a division sign, you are going to subtract. And then if you see a something to the x power, you're going to bring that up out front, okay? All right, so let's do this one. The next one is a division. So I'm going to separate. I'm going to have log base 6 of 12. So this first one goes first, right? So that goes first. And then log base 6 of 5 goes next. And then my division turns into subtraction. Now notice, every time I write this, I have log base 6 on all of them. Over here, I had log base 7 on all of them. So whatever your base is to begin with, that's what I'm going to use. So notice here, we have multiplication again. We have x squared times x to the 7th. So I'm going to separate those with an addition sign. Now, but notice, I'm not finished. Like in A and B, I'm done. But in C, do you see that I've got these exponents up here? You cannot have exponents. Time you have those exponents, you have to move them up front. So that's going to be my next step, is to move those to the front. And so now I am done. I've got I have no more exponents. I have no multiplication. I have no division. Remember, answers have no exponents in them when you are expanding, okay? This one's a little bit different because I don't have an exponent. I have a cube root. But remember, we can write the cube root as an exponent. So once I do that, I have to bring my exponent out front. So my final answer is 1/3 log base 2 of 9. And we're basically doing the same thing in letter E. It's just we have a whole bunch of letters, not just numbers. So now it's log base A of the 5th root of r to the 3rd. So now that's log base A of r to the 3/5. And I'm just going to take those 3/5 and I'm going to pull it down front for my final answer. And then in F, notice that I have some division in there. I've got division and I have multiplication. So I'm going to start with my division. So I'm going to write log base A of m to the 2nd. And I'm going to subtract this guy. Okay, this on the bottom, log base A of n to the 3rd, p to the 5th. So next, I'm actually going to have a trap because notice this is times, but whenever you break that apart, my trap is that I was subtracting this whole thing. Okay, I was subtracting that whole second expression. So when I'm subtracting, and I separate those, I need to separate my n to the 3rd and my p to the 5th, and I separate it with a plus.
If I do not put the parentheses, then I would miss it, because once I put the parentheses, I've got to distribute that negative. So this turns into a subtraction sign. We are almost finished. We do need to distribute, and notice what else I did there. I have these exponents. All exponents must come in front. So that was the next thing I did. You didn't really have to do it in that order. You could distribute the negative first if you wanted. It doesn't really matter, as long as you wind up with your final answer as 2 log base a of m, subtract 3 log base a of n, minus 5 log base a of p. And again, that minus is the thing that most people miss in this type problem. Okay, we have 2 more. This one is very similar. G is very similar to F. We just have more stuff on the top. Okay, so I'm going to once again do my division first. So I find the first, I separate the first, the top one, log base b of r s to the second t. And then I have my second one on the bottom, and I put subtraction in between because it was division. Notice I went ahead and put my parentheses there. My next step is to separate all of these guys. Okay, so I want to separate them all, which I did. Notice I did not put a parentheses around the first ones. Now you could if you wanted to, because these guys do go together, but those do not matter that much because I'm adding. This is the guy that I'm subtracting that I really do have to watch out for. So that's why I put those parentheses. Don't forget that you cannot have any exponents. So any exponents you have, you must bring to the front. That's honestly why you do logs most of the time. So I'm going to bring those guys to the front. And then last but not least, I'm going to distribute that negative. And once again, if you would prefer distributing the negative up here as soon as you get a negative, you can. It doesn't matter which order you do it in. And here is the last one. Notice the last one is all letters except for the exponents. So my answer is going to have just a lot of letters in it. I'm going to start off, actually, I'm going to start off instead of division. I'm going to get rid of my mth root. So we're going to put a th on the m. So I've got to change that to r to the third, s to the second, divided by t to the fourth, quantity raised to the 1 over m, because remember this guy is the index, is the index or the root, so it goes on the bottom. Now there's multiple ways that you could work this problem. You could bring this guy out front at the very beginning and then have just a parentheses the whole way and not deal with fractions until the very, very end. But I did it a little different this time. I went ahead and put this m, I went ahead and put my m, where did it go? Let's try, I went ahead and put my 1 over m, I put the m underneath each one of these, and the add a 2 on it, So I'm going to put my m underneath each one of those. Instead of having a 1 under there, I just put an m under there. And then I'm going to do the same thing that I've done in the past, where I will take my division and turn that into subtraction. And then I need to take each one of the multiplications, which in this case I just have one multiplication, and turn that into addition. My very last part is, of course, these exponents. You're not allowed to have exponents, so those all come to the front, and you're going to get a really weird answer. But you started with something really weird. So 3 over m times log base a of r plus 2 over m log base a of s minus 4 over m log base a of t. All right, so that is expanding. that is really just getting you ready to start condensing, okay? So condensing means I'm going to go at my answers, instead of having 3 logs in the answer, it'll just be one log base 4 of something, okay? So the first thing I notice is that I have a subtraction sign. So my subtraction means I'm going to divide. So I went ahead and did the division. Notice I don't do it all at one time. I just did my division part. I just did the minus first. Now, what is the plus? Remember, plus means multiplication. We could go back and forth. So that's what we're going to do. And division, let's see, subtraction is division. All right, so we are going to multiply. So I'm just going to put that on top. So you could think of that as log base 4 of x over y times z over 1, if you want to think of it like that. So that's why my z goes on top, right? Because that z is over 1. And that's your final answer. We went from how many logs? We went from 1, 2, 3 logs to just 1 log, okay? Where students usually mess up is they'll write log base 4 of x over log base 4 of y. That doesn't help us at all. It didn't get rid of any logs. So we want to make sure that we get rid of our logs. Okay, so with the next one, B, notice that we have a 4 in front of log B, base B of R, and we have a 5 in front of log base B of S. So those are exponents, or they are going to become exponents. I'm going to move those guys up first. That's my first step, is to get rid, or to put my exponents back where they belong. Then subtraction, remember my subtraction is division. So I'm now going to divide. And each time I do a step, I'm reducing my logs by 1, right? So here we went, in this one I had 3 logs, then I had 2 logs. My final answer has 1 log. This one started with 2 logs. I end with 1 log. So again, the very first thing you're going to do is, if you have any kind of exponent or any kind of number in front, you're going to put those up top. Those are going to become the exponents. So I do that first. Then I have addition. Remember, addition just means multiplication. So I'm going to put those 2 together by multiplying. Notice I just did one thing at a time. So I just put those guys together. And then what is my subtraction? That is division. So now I'm going to put this xy on the bottom. And we would be done, okay? We would be done, except there's something neat that has happened. Do you see that the bottom of these guys are the same? Do you remember what the bottom is? It is a root. It is the root. So they have the same root. So I'm going to write it. I'm going to write them with the same root. And it is a cube root. So I have written, notice I have my x to the 1/3. So the 3 came on the outside. And notice where the 1 went. That is my exponent, which I didn't really need. You don't have to have 1 as an exponent. But on the y, the bottom is a 3, so I took care of that with my cube root. And the top is a squared, so that goes underneath the cube root. And so finally, I'm just going to get rid of that little 1 on my x. So the final answer is log base a of the cube root of x y squared all over xy. Now here is a trap, okay? So the question is, can I distribute a log? Can it be written like this? Can I distribute a log? Why or why not? Well, no, you cannot distribute, because that x plus y is super glued together. And this log is something you do to a number. It's not a number itself, okay? So I cannot distribute that. Now I could, if it was, notice that I just added, instead of just log base 3, I had log base 3 of 5. Well, log base 3 of 5 is just a decimal, and you can distribute a decimal. So if you're taking the log of a number and distributing that, that's okay. But if you were just trying to distribute a function, that's like distributing a division sign. I can't take a division sign and distribute it to x plus 2. You can't distribute division, okay? And you can't distribute a log. Okay, last thing. So we're going to be able to find a log without using a calculator. Now, this isn't nearly as important as it used to be. You didn't have calculators, and so they have books. And I can't find my father-in-law's book, but it was about 3 inches thick and about, 6 or 8 inches long and about 6 or 8 inches wide. And all it was a list of logs. He was a physicist, so he used it all the time because calculators didn't do what they do now. Anyway, this is just having some geeky fun. Are y'all ready for some geeky fun at the end of this video? Okay, so he would look up log base 10 of 7 and get this approximation, okay? Well, that's not what he needed. He needed log base 10 of 49. But he didn't have that in his book, but he had this guy. He had log base 7. So he remembered, 7 squared is 49. So he just rewrote it, log base 10 of 7 squared. And then notice I have an exponent. So I'm going to bring that exponent out to the front. So that's 2 times log base 10 of 7. Well, we know log base 10 of 7. So we just multiply 2 times that, 0.8451. So now we can find the log base 10 of 49. Now let's do another one. Log base 10 of 70. Well, 70, I can't do 7 to some power, right? All I have is log base 10 of 7. I can't do like I did here, where I just do it to the power, but I know that 70 is 7 times 10. So I can do log base 10 of 7 times 10. When you have the plus sign, when you have the time sign, remember that just means we are going to add those together. So we now know what log base 10 of 7 is. We've been given that one, right? So we have that. But you might be thinking, well, they didn't give us log base 10 of 10. But if you remember back when I was giving you these formulas or the laws of logs, I had one that said log base a of a to the x is x. And remember me saying if these guys are the same, it just cancels out, and that is your answer. So these guys are the same. What exponent is understood to be right there? That is a 1, right? So all these guys are just going to cancel out, and I just get a 1. So that's going to be 0.8451 plus 1. So that's my final answer. And that is the end of 4.3.